coming through okay?
Sorry?
Okay, can you see my screen okay? And can
Yes,
you hear me okay?
I got it.
Oh,
I saw it.
okay, all right. Okay, great. And hopefully that's fine for everybody else. Thank you, IOSH Hong Kong and also IOSH elsewhere in the world for inviting me today to speak on design for safety. And also thank you to Raymond and HY for the arrangements for today. So this is very much a personal perspective on design for safety. So I'm Robert Gordon. I'm a qualified civil engineer by training, and I'm also a director for Bureau Happold in Hong Kong as my day job. And I'm also the chairman of Lighthouse Club International, which is a construction industry organization for fellowship and charity, which operates extensively throughout Asia, Hong Kong in particular, and other countries of the world. And I've also been a past chairman of the Lighthouse Club Hong Kong. I'm a committee member, and also I'm a member of the safety subcommittee, which is how I've also been introduced to give this talk to you today. So I hope you find this interesting. And I appreciate it's hard to cover everything in the space of about an hour. So if you do have questions on what I'm presenting today and you want to follow up with me after today, or you don't get a chance in the Q&A, then I'm happy for you to contact me on the email address I've just put on the screen. And really, I want to cover today why design for safety matters. I'll give you some of my opinions on root causes for safety incidents and the linkages with the design decisions. I'm going to go through also a little bit of the current landscape of the regulatory or legal requirements for design for safety and how that fits with the Hong Kong landscape. And also I'm going to talk a bit more about how designers are implementing design for safety, and also think about what more, can we do? And I think a good place to start, and I'm sure a lot of you have access to these statistics, is from the Labour Department in Hong Kong. And what we can actually see is that the accident rate since 2021 has actually started to climb, having made some improvements over the preceding years. And hard to know if that's statistically relevant, but also we do have to ask if design for safety is a root cause in any of these accident rates increasing, or indeed for the current accident rates. There isn't really enough data there, but it's just, again, a personal opinion that design for safety or designers' decisions is often a root cause of the incidents you see on site. And another statistic we can look at is the fatalities. And again, in the construction industry, we can also see that fatalities, since having made some improvements up to 2016, have started to go the other way. So are we making things worse, or is it such a low number overall that statistically it's going to vary anyway? Let's hope that we can reverse it, because that's what we want to do. I'd also like to use this opportunity to do a little quick advertisement for the Lighthouse Club in Hong Kong. We are a non-political organization. We provide fellowship for the construction industry, but what we also do is we provide charitable assistance to frontline workers that get injured. Sometimes it's a fatality, and we also help out the family of those that have been affected and so on. And certainly, if you do make donations, 100% of your donations go to those in need. There's no admin costs at all. So please have a look on the website with a link there. And if you want any questions or have any questions about Lighthouse Club, feel free to ask me.
Sorry, Robert.
Yep.
Sorry, Robert. Your screen will not fully explore your PowerPoint. Could you mind, because we have a locked side. Will you change the screen?
Okay, let me Let me try. Maybe if I do this.
Okay, this one should be better.
It might be a function of how I'm presenting.
Okay, you
maybe
open
if I it sometimes happens for those of you with the IT knowledge that sometimes if you've got multiple screens going, it does do that. Does that? Can you see everything on the screen now?
Yes, so it's better. It's better.
Okay, maybe not perfect, but I think it's the way the screens are linking up.
Okay, sorry for news. Thank you.
Hope that
thank
works
you.
for you. Okay, thank you for pointing out. Okay. Okay. So I'd also like to say also that the views and opinions here, that they are my views and they don't necessarily represent those of my employer, Lighthouse Club, or other organisations. And again, there may be some copywriter issues as well, so please don't copy what you're seeing today. But I'd like to really go through, in fact, I do need to perhaps go to a slideshow mode. So I think that if I'm not in slideshow mode, is that going back to the notes slide? Or can you see the
two screen? I see a two screen.
Seeing two screens. Let me just wondering if I can try like this. Let's see if this is that better?
Yeah, better.
Okay, apologies for the technical glitches there. Let's see if this works as I go through. I'll see you on the next slide if it has. I want to point out that this is a shed in Germany going back to 1998, where there are a lot of people dead and injured from an accident. And what we see here is effectively a train incident, and we can see that the train has derailed, the bridge has collapsed onto the railway, and there's a lot of people involved in the rescue effort here. And what I want to point out here is what's actually the sequence of events here, and what is the root cause. So the bridge has collapsed onto a train, it's quite clear to see, but the train has demolished the bridge pier, and the train has derailed prior to that, and the wheel has been caught in a rail switch. It was caught in a rail switch because there's a defective wheel in service, and a defective wheel has not been replaced. Maintenance regime missed the wheel defect. The train wheel was defective already, and you can ask questions about whether the wheel design was adequate. But I'd like to focus on the highlighted area, which is the fact that the train demolished the bridge pier and collapsed onto the train. And the question really is, could we have saved more lives at the design stage if the bridge deck had not fully collapsed? And there's an example where a few years later from this event, I was overseeing design of overpass bridges on the Taiwan high-speed railway, and actually designed and built into the design criteria that if a bridge pier is demolished by a derailed train, the deck will still remain standing. It might mean that it cracks, it deflects, has to be rebuilt afterwards, but it won't fall down onto the train at the time of the incident. So this is one of the key factors going back to design for safety, that had the designers of this bridge thought about it, then perhaps fewer people would have been killed and injured. There's another incident that happened back in 1999 on Avonmouth Viaduct, and I was actually on this project as a junior assistant resident engineer, and 4 people died in this incident. And what you can see here is there's a gantry that's hanging down and looks a bit broken, and actually it's supported. This whole gantry is supported on gantry rails that run on the underside of the cantilever of the bridge deck. And it shouldn't be there, it should be on the other side. And this is, I've just put in blue a key plan. So area 2 is, this is the north approach, and area 1 is the south approach, and the flat area is the main span. And this gantry should have been near area 1, not area 2, which is more than 1 kilometre away. And what's happened is that this gantry is hanging above a gas bottle supply, which could cause other issues if it fell down. There's a vertical Alimac scaffold carrying the lift from ground level to the deck level for the bridge strengthening works, which has been shunted over by a metre from the impact. And that gantry had acted like a sail. Basically, it had fallen down into this vertical position, acted like a sail, picking up the wind and going along the rail before it hit the gantry here, before it hit the Alimac here. And what's happened earlier at area number 1, further along the deck, is that the lower end of this gantry fell off the end of the rail, tipping 4 people out, 20 meters to the ground. And you would think that with the slope of the approach span, that securing it from falling downhill would be the issue, but actually it blew uphill. And what was happening was there was rail works going on to replace the gantry rail. So what would happen is people would come in and they would take out a section of rail above and then put in a new section of rail to replace. So that old gantry rail between the temporary work supports was removed. And although it was secured from going downhill, it wasn't secured from going uphill. Now, when that gantry was moving into position, it was moving into position with new gantry crew for the day. So it's possible that they missed one of the steps in securing the gantry from going uphill. But whilst this has gone through the courts and it's a well-documented case, one of the thoughts going through my mind is the fact that 4 people fell out. And was it possible to have a different replacement gantry rail design? Could have the temporary works design been on a different alignment to the permanent works, or vice versa? And therefore the risk would have been eliminated at the design stage. This is a store in Riga. 50 people died here, and this is the aftermath. And you can see that the roof has collapsed. It was in the news at the time, and the newspaper article was, "The weight of the soil for the garden, made heavier by recent rain, will be closely examined." So the question is, did the designers consider the saturated weight of soil for the green roof after it's been raining? How about the deflection of the roof under additional superimposed dead load than perhaps it was designed for? And what was the effect on deflection of the roof structure on the drainage paths under load, and the potential for retained water depth adding to the load incrementally? And I haven't seen the report for this collapse, but undoubtedly there was a linkage here. And the question comes up, well, this is Riga, it's not Hong Kong. Should we be concerned? We have very high standards in Hong Kong. And it's true that we do have high standards in Hong Kong, but then we had this. And you may recognize this. It's basically 3 years after Riga, time enough for people around the world to learn lessons. 2016, City University, Hong Kong. 3 people were injured, and it was a sports hall fitted with a new green roof, which had collapsed on a hall that had been used for exams. So you can imagine that had that hall been full of people at the time of the collapse, the casualties would have been much higher. And we can see another example, a very recent one you can see from 2022, and some of you on the call are probably maybe even more familiar with this one than I am. but 3 people were dead and 6 injured on this site. And it was an unloaded tower crane that collapsed onto site accommodation. There might be a report out by now, but I believe it's under investigation. But I think that we have to ask ourselves, was this a failure due to installation error or temporary works design failings, or a combination of factors? And could the temporary works designer and the checker have done more? Was there enough redundancy built into the design? Was it easy to build? Was it easy to build without too many defects in the construction? And so the question is it a design for safety issue as a root cause? Those are some examples of why design for safety matters. And I thought I'd also touch on the current landscape for design for safety in Hong Kong. So there is obviously, for those people from the UK on the call, people will be very familiar with the CDM regulations, which was enabled by the Health and Safety at Work Act 1974, first issued in 96 and has been revised since. But it sets out what people involved in construction work need to do to protect themselves from harm and anyone the work affects. And it then goes on to say, whatever your role in construction, CDM aims to improve health and safety in the industry by helping you to plan the work, have the right people, cooperate and coordinate, and have the right information and manage the risks. Communicate it all so that everyone who needs to know knows, and consult and engage with workers about the risks and how they're being managed. So it really is a full life cycle appreciation of the health and safety risks, starting from design. And we can also look at similar legislation that's been enacted in Singapore for design for safety regulations in 2016. And if we do look through here, we can actually see very similar requirements, the duties on developers and designers, a review process that's needed through every phase of the construction project, a register for all projects, and the appointment of a design for safety professional, and mandatory on all projects of a significant value. So there are some good examples of where legislation is used to help enforce design for safety. And to the best of my knowledge currently, in Hong Kong, we have guidance notes through the works bureaus that have developed this, but this is only guidance, it's not actually legislation. But it does follow similar principles: identify and minimize hazards which may give rise to risks, reduce risks due to design and inform the parties, cooperation with project supervisor and other designers, provide the information. And what I think is probably missing is that this really is just voluntary guidance, and it does not have sufficiently wide coverage. So if you look at the root cause for many site and in-operation facility incidents, they can be directly and indirectly traced back to designer decisions. So if we want to have compulsory implementation of CDM or something equivalent to it, it does require legislation to get everybody on board. Otherwise, it's purely voluntary with organizations, public or private, that wish to do so. And only in Hong Kong, only the government has the power to implement that legislation. But construction industry bodies can lobby the government. And I would say that people like ourselves, everyone on this call, particularly those in Hong Kong, can approach our respective institutions and our bodies who represent us and ask them to lobby the government. But we also have to recognize the flip side of this. There are certainly interested parties that may take on extra liability, and they don't want it. And of course, nobody ever does want the liability. But it is the responsible thing to do. And I think that people who particularly own assets and drive the requirements for assets should have an involvement. And really, the effort for this is because we want to save lives. We want to save people from horrible accidents that cause horrendous disabilities, time off work, and distress to our families. And it also seems that We only get action taken when a major accident occurs. It's headline grabbing, it's on the front page of the news. Somebody gets put in a good political light for taking action, and also scapegoats are sought. Someone always has to take the fall, someone is to blame. But it's a very reactive approach. And if we have legislation and the training and all the support that goes with it, it becomes proactive. And I would challenge ourselves to say, can we change the paradigm on when we take action? So design for safety is about aiming to prevent before we implement. There's no ordinance in Hong Kong to cover it. And I think that if we had a Hong Kong version of, for example, the UK or Singapore version of their regulations, I think it would help to improve our health and safety in Hong Kong, more motivation via accountability. So there are bound to be people on this call that agree or disagree with that, but I think it's worth putting it out there. Now, on a more positive sound, we can look at how designers are implementing design for safety and what more can we do. But we probably need to think about who are designers. And it's easy to think of consulting engineers, but really I think it's anyone or any organization that prepares or modifies designs, BIM models and drawings, specifications, bills of quantity, design calculations, because this affects anything that can be built on a site. And as a result, that designers can be organizations or individual people, architects, interior designers, consulting engineers like my good self, QSs, anyone who specifies and alters designs, contractors, subcontractors, tradespeople if they carry out any form of design work, and you may think of a few others as well. Now, I'm going to share some examples. These are a mixture of my personal experience, also of entries from the Lighthouse Club International Design for Safety competition. And I'd like to emphasize the purpose for sharing it. It's really, I'd like to share some good examples. We might look at them and feel that there are improvements that could be made to these. I think we always appreciate there's always room for improvement. So I wouldn't say they're all perfect examples, but I think that at least they do get across the spirit of incorporating design for safety. So this was an entry from Oricon, David Law, Swanston Square, the Malt House in Melbourne, Australia. So it's a historical building that was dilapidated, had been abandoned for 25 years, a former brewery building, and was going to be part of a new office development. And what I liked about this one was that there was a full consideration of the properties of the materials of the building, given it was a historic property. And they'd also given a lot of consideration to how the structure was working, how the load paths were working. And that's very important if you're trying to understand the influence of your new design on the existing structure. We do have examples of existing buildings in Hong Kong that have been modified and they've actually collapsed during construction. So in this particular example, they did a very good job of it. It was reviewed for construction, demolition, strengthening works, temporary stability and construction loads. And they'd also sought to minimize the steelwork connections, in particular above some tanks that were being left in place. And that also reduces the future maintenance access need in difficult to reach areas. In the design drawings, they'd also highlighted all the residual risks. And they'd also built some flexibility into the design to cater for on-site conditions not matching those known at design, because with an existing structure, you're often uncovering elements that people have not been able to inspect or properly understand before the contract works are awarded. But what they'd also done was built in facilities for all the spaces, including some hidden areas, to be accessible for inspection and maintenance. So you didn't need any special kit to go and inspect parts of the building. There were openings and doors put in that were safe to go through. Now, bringing it home towards Hong Kong, this was a good entry from Arup and Simon Pickard on the M+ Museum, West Kowloon Cultural District. They had to put a new museum building above existing railway lines, which were in tunnels. and also on reclaimed land. So quite a tricky site. And the facility is, as I'm sure all the Hong Kong people here on the call will know, is fully open now. But what they did was they limited the depth of the basement excavation. The more depth is the more risk. And that also meant by reducing it, there was less exposure for the construction later. They also built in high-level access walkways for maintenance for the MEP plant and lighting. So basically, one of my favorite questions to anybody on design for safety is, how do you change the light bulb when it's 5 meters up in the air? And if the answer is you need to get some special kit out and you need PPE, you've failed the first exam question on safe access to change a light bulb. In this case, from the high-level access walkways, you can safely access the light bulb and you don't need any special kit to change the light bulbs. Now, they took it very seriously. They had design for safety gateway reviews at 30 and 70% and 100% of the design stages of each design stage and across all the disciplines. And they also enabled an advanced works contract to look at the buried utility locations and diverters needed. So that also helped to remove some of the in-ground risks. And they also provided construction sequence diagrams. And I always think that any designer must always come up with at least one plausible method of construction. And I think they should also show it on the design information to show to contractors, yes, I've thought about how I'm going to build my asset, and I've come up with a feasible method. I understand the plant and the temporary loads and the construction loads to build it, and I've allowed for it. And in this particular case, it also allowed for facade cleaning and maintenance strategy, including for facade replacement from inside the building. So they'd actually designed it that you could replace the facade from inside the building. Now, here's another example. This is the Liantang Hung Yuan Wai border crossing point road and tunnels. And there were some challenges with this one because there were 48 8-meter diameter cross passages for a 4.8 kilometer dual 2-lane tunnel. Tunneling through volcanic rock, high water table, variable ground conditions. And at the time, there was no topside access for further ground investigations or pre-excavation grouting. So this had high risk written all over it. What they did was they looked at having a horizontal pre-excavation grouting from the first tunnel bore to increase the extent of the grouting. Also eliminating and reducing MEP equipment in cross passages by design to reduce the diameter. So if you can reduce the tunnel diameter of the cross passages, you've also reduced the risk. And ultimately, they did insist on topside access to get that further ground investigation to understand the ground conditions. And I think if ever you're tasked with a project where they're not giving you access for the ground investigation to properly understand the risks, I think you do have to insist on it. And this is a good example of that insistence paying off. Also, they used experienced designers experienced in soft, poor ground conditions. So this comes back to not just the fact they had tunneling engineers, but they had people experienced in these particularly challenging ground conditions. So it's very important as competent engineers to understand the limits of your competence and know when you need to bring in expertise to assist you. And also, they built in a specialist ground treatment subcontractor as an experienced supervisor, and developed a special and optimized grout mix with a grout supplier and grout treatment subcontractor. So they weren't leaving anything to chance here. Another example is out at the Tuen Mun Chek Lap Kok Link Viaduct project in Hong Kong. And what you're looking at here is a precast concrete pile cap shell. And it's a marine pile cap and using match cast concrete shell modules. It was quite an interesting challenge here to build the pile caps above the water. So what they did was off-site pre-construction to test the design before being on site. And they reduced the number of man hours, which also risk the exposure. Match casting the adjacent sections also minimized the tidal working. And because of that, they had self-aligning sections, which were more precise and watertight from the word go. And the use of these precast and pre-stressed shells mitigated the need for welding. And each shell, which is supported on piles, forms a watertight, safe working area for the pile cap construction. So the bottom level of the caps were also lifted to be above the low tide for around 2 hours a day, which also gave certain construction access. And the shells also provide additional corrosion protection. Again, that's very good for long-term maintenance needs. So again, there's also an enhancement for the final built asset. Now, here is also a nice picture showing you how they stress the sections together and that precast shell being in place. Another example here is on the Charlton Central Link 1121, a contract I was working on, and this is the casting basin at the old quarry at Sheko. And this temporary dock gate was actually built out of precast concrete blocks that actually came from another MTR job. But basically it was needed to safeguard the dry dock area. And all these concrete blocks came with lifting eyes. So with those lifting eyes, it's very easy to lift them into position, drop them in position, very easy to construct, and also very easy to deconstruct later when it's time to let the water back in. So in this dry dock, the immersed tube tunnel units would be constructed, and when it was time to float them out, they'd deconstruct the dock gate, let the water in slowly, and they'd be able to then float the units out for the construction of the tunnel. And indeed, as you'll know, in Hong Kong, the tunnel's now open for service. This dock gate was also designed for permanent loading, even though it's a temporary structure. It was designed for the wave action. It was also designed for accidental vehicular or sea vessel impact. And there were grout pipes behind the sheet pile wall acting as a secondary measure in case there was water ingress. So it gave you an opportunity to tighten things up. And there was also gravel fill and drain pipes beneath the base of those dock gates to release the water pressure. So again, lots of belt and braces measures to keep people safe behind. And during the construction, fast setting adhesive anchors were specified on the existing abutment walls to minimize diver works in the water. So quite a few measures implemented to safeguard the dry dock area. And there's a picture of the dry dock basin as it was under construction. Moving to Singapore, an entry from EFT Craft, Sabrandus Weeches, the Singapore Sports Hub cladding installation. I've shown this picture because I think it gives you an appreciation of just how high that roof is. The exposure of trying to do work at height here is enormous. And the original requirement was to install that roof and soffit cladding in situ. But instead, EFT Craft looked at prefabbing those units at ground level using ground level jigs, quite large ones. And that reduced the number of labourers needing to work at height by more than 75%, which I think is fantastic in reducing the risk. And they also simplified the details and the bolted connections to also further reduce the need for workers at height. And one thing about simplification is that the simpler a design is to actually build, the more likely it will get built the way you intended and without any incidents, because there's less opportunity for people to make mistakes or get confused or to not follow the instructions. So there were no welded connections, all bolts and screws. That also helps with the quality of the work. And they also did 3D scans of the cleats from the ground level, then did a computational analysis of those to understand what alterations were needed at ground level before anything was lifted in place at height. And also by standardizing the cladding panels, it also mitigated handling, coordination, and installation errors. So again, quite a few measures here to improve the safety of the built asset for construction by design. And here, again, maybe not a perfect example, but it shows how they're building the cassettes for installation at height. Moving over to Macau, the Parisian Macau, this is a replica Eiffel Tower, so this is not the one in Paris. And it was the construction of the tower and the link bridge. Very complex, slender, high tower. And it was designed for the temporary scaffolding supports to be integrated into the permanent works design. And something that I think designers can do an awful lot of is to consider how they can adapt the permanent works to enable the temporary works and vice versa, so that you can minimize the stages in construction and the amount of works needed. In this case, steel modules were fabricated at ground level, also reducing working at height. And there was again a lot of standardization and simplification of the connection details between the modules, again limiting the whether errors can be induced by workers and so on. Now, something I want to mention here is important. We're in the digital world these days, and certainly BIM has become more prevalent throughout our industry, and there's a lot of digital tools now there. And digital tools like BIM can be used to build the works before you build the works in the digital environment, effectively a digital twin of what you're about to build. You can check crane capacities, you can check the routing of all your elements, you can check for finger traps, you can really optimize the sequence for safety. Within the permanent works design, this also included a maintenance walkway incorporated into the link bridge, which means that you have safe access for future maintenance without the need for PPE. And also on the tower itself, there are a lot of decorative elements, and they were originally going to be cast iron, but why put cast iron elements, decorative elements, 30 meters above the height that anyone can see them, when you could have glass fiber reinforced polymer elements that look the same, are much lighter in weight. It's much easier to lift into position. So you can improve the safety also by being more careful about material selection. And in this case, they just used the cast iron ones where people were basically at ground level and could see the elements very close up. There's again a picture of it under construction there. Bridge construction has often been good examples of mechanized construction. This one's from Lambeth and Gammon for the Chiltern-Shepnap-Cock Link Southern Connection viaduct section. A new mechanized method for bridge construction, and you can kind of see the K-frame design there for these temporary works. Basically looking at factory production methods using very lightweight machines, a kit of parts approach to the machines, standardized modules, good control systems, and a minimal learning curve for any worker having to operate them. Also, redundancy built into the design. And I think that's also a key thing, that things do go wrong in construction. Sometimes there are quality issues, but if you built some redundancy in the design, then you're not too close to the bone. And if there is a mistake on site, chances are you can work with it. So it does add additional safety and reliability. This machine was also single operator run with a handheld remote control unit, hydraulically controlled movement on skidding pads, so it's not wheels, so you don't get runaway situations, particularly when you've got gradients, on the highway to deal with. And again, similar to the previous example, they used the BIM. In this case, they're looking for things like finger traps and safe working zones and so on to make sure that they can safely move the machine. And these are, the family of the K-frames that they came up with for the project. Moving on to the Hong Kong-Zhuhai Macau Bridge passenger clearance building. That's quite a complicated roof to get built. How do you erect it safely, close to the airport with height and radar constraints? And when you look at it, it's got this air height restriction of 38 meters, and the final roof height's 36.5 meters. So you're not going to be able to use cranes to erect the roof. You'll just breach the safety limits. So the answer was to prefabricate roof modules and integrate as much as possible into the roof module as possible off-site, barge it in, bring it aside, put it onto SPMTs and move it into position. And the SPMTs was worked out how to move them into position, the routing, orientation, how long it takes, and also thinking about how these elements could be jacked into position, the sliding rails to move them along. And you can see that it moves like a cassette, one section after the other, and also an allowance for typhoon tie-down areas, so that if the bad weather comes in, then the units can be tied down safely in pre-arranged locations without any risk of collapse. Once you've done these, main units like these, you can then come back and do the infill units and jack those into position as well, and end up with a finished product. What's interesting to note here is you can also see the temporary working platforms built in, again minimizing the risk of working at height. So in summary, this was designed for construction, modularized units, including the cladding and prefab offsite, a conceived erection method which minimized working at height. And this was all conceived at the design stage and then fully brought on board by the consultant that helped the contractor, and the contractor ultimately to build this. And there was a lot of repetition in the process for erection, which also minimizes the learning curve for each module, the temporary access workways, tie down areas, and also it eliminated the risk to flight operations. Another good example here is on contract 1111, the Hung Hom North Approach tunnels. And this was the use of traveling adjustable table form and false work. So you're not erecting and dismantling each time. You can just slide it along and adjust for each section of the tunnel. That means minimal setup in the subsequent bays. It reduces exposure to working at height and all the lifting. And it's also very easy to train and direct the labour workforce. So this is an example by Dragage on contract 1128, which is the South Ventilation Building to Admiralty Tunnels. And they had to build some shafts to give access for the tunnel boring machines to come in. And this image on the left is how you would traditionally go about it, with the lateral support system, the cross bracing that's needed. But as you go down, you can see that the tunnel bore for one railway line is higher than the other. And this creates an issue in what you're going to do with your temporary works down below, where you have to remove some struts. That's quite a big risk. Also, with this kind of layout, you only have very limited space to lower in the kit that you need for the TBM machines. So quite a difficult shape to work with, and a lot of potential risk for collapse of the shaft at the base. And this was solved by adopting what Dragage called the peanut shaft. And what this does, this utilizes the hoop stresses, minimizing the need for any cross struts, just a couple of cross struts in the middle in order to take the stress. So this was an excellent design solution. And you can see that it maximizes then the area needed to be able to lift elements in. So it resolves a lot of those design for safety issues. It frees up the space. It also reduces the ground settlements because of the way the peanut shaft operates. And it removes that lower level strut stability issue. And it also, for that complex strut installation and removal process in the traditional shaft, it also eliminates that risk. Now, they went one step further, and basically they installed these concrete bells and thrust frames in order to launch the TBM. So this was a new way of thinking about how to launch a TBM without having a very long, effectively, train for the TBM to launch. And it left a lot of space for the TBM, or the space behind the TBM, for other elements of construction. So that thrust is transmitted within the star wheel, the concrete block and stressing bars. It reduces the space needed for traditional TBM launching. It increases your temporary site storage areas, and also that concrete and steel bell pressurized chamber balances external soil and water pressure before you actually break the ground with the TBM. Also mitigating risk of inadequate jet grouting and impact on adjacent structures. It mitigates that risk of dismantling what would normally be a 10-meter long steel bell in a constructed tunnel. And the concrete bell is incorporated into the permanent works, so further enhancing. And there were some other permanent works also, such as the escape staircase that was redefined and redesigned to delink it from the TBM activities, which also enhanced safety and provided an EVA and access during construction. But design for safety doesn't have to be so fancy. There are much simpler implementations of design for safety that can be considered. And here's one which was just a drainage scheme, a village sewerage scheme by Black & Veatch, using intermediate pumps to reduce excavation depths rather than just simply digging deeper and deeper trenches and laying pipes to those. Using trenchless tunnel eliminates the work in trenches, and also mitigates the risk to adjacent property. So in this village area, a lot of people were worried about the impact on their property and businesses along very narrow alleyways, and also the choice of material. So using HDPE, the material has a longer service life, so that also means a longer time to wait before someone will be interrupted with maintenance needs. So all in all, a very good solution. We come to Hong Kong West Kowloon Terminus Station, and Gammon were tasked with building this plenum. And this plenum, you can see, is this space above the platforms and tracks, but below the structural slab, and it's 8 meters above. So how to build this safely? Well, all of this was to be implemented in situ with an 800mm working space, which is really a bit of a non-starter from a safety point of view. And the answer was to come up with a different design detail, utilizing steel columns, steel beams, and using precast concrete elements in order to effectively provide prefabrication, a kit of parts approach to building the plenum. And we can see that the finished article actually still achieves everything that the original design was setting out to achieve, and also provides future flexibility if they do need to come in and work in that space for any reason. And the finished article works very well. So it meets the original design requirements. So the question is, could the original designer have come up with this? Stub hanger columns, steel hanger posts, steel grid and lightweight concrete infill panels, in this case the Waitong panels. Perfect safety record during construction. 98% of scaffolding was eliminated. 98% of in situ RC work was eliminated. A safe working environment, off-site prefab, and 3 months off the critical path. Now, saving time also means less exposure time of any risks on site. So that's also a good thing from a design for safety perspective if you can shorten the program. This is another machine from Gammon, where again, using skids and skates instead of wheels, dealing with steep gradients. Hydraulics designed to lock in case there was a hose failure so it doesn't run away. A very wide chassis to eliminate any toppling risk. And again, digital models used to remove man traps, finger traps, and make sure it's safe to move. I'd like to now move on to, this was from my personal experience actually, a bridge I designed back in the 1990s in Anglesey. It's an integral bridge, so it's designed to minimize the future maintenance needs, but that means there's no movement joints and no bearings, which is great for the future. But when you come to demolish this bridge, these abutments were not designed as freestanding abutments. So the deck actually props the abutment when the backfill is in there. And that means that the bridge, the abutments need to be propped when the deck is removed. Now that demolition sequence was provided to the client at the time. But I think if I was looking at this one again, I would probably design this as a freestanding abutment and remove the risk entirely. But it also highlights the need for designers to consider the demolition sequence and to particularly include it if there's an unusual design. And you could argue in every case, a designer should consider the removal or demolition sequence. This is A40 Western Avenue Bridges replacement in London, and this was building over the Great Western Railway, a railway that operates 21 hours a day, 365 days a year. And it's the main road into London, carrying some major services. And the beams here were lifted in pairs with cross bracing you can see between for temporary stability. And you can also see the steel deck that was put in place between the beams, which provides a safe working environment above the railway with all the shear studs in there. And later someone can come along and do the concrete pour to make the composite deck. But it creates that safe working space above the railway. Also, the choice of material. By design, it's weathering steel. So weathering steel, when it corrodes, forms a layer of rust, which actually is then impenetrable, and it never decays after that. So it's quite a good material to use over a railway. You don't need to repaint it, and that means less access to the bridge in future. We also had to consider during design to limit ground settlements, and therefore caissons were used instead of piles. And we come to another example a bit further down the road of a bridge that had to be installed. Now, it didn't start out this way. The original thought was to actually put a toucan crossing along this busy road. But actually, the story on this one is that there was a Bailey Bridge crossing the road just out of picture here. And it was dilapidated, it had been struck by a vehicle, it was due to be removed. And a toucan crossing at grade was going to be placed here. But a blind man came along and said, well, if you put an at grade crossing in here, I can hear when the traffic light goes beep, 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 but I can't see that the cars have stopped. He had a good point. So in agreement with the client, we changed it to a bridge design, which is what you see here now. So a crossing to replace the dilapidated bridge, but it wasn't the original idea. And it was basically a blind resident that forced all of us in the design team to rethink, and I think it was a great thing it happened. And the main span was fabricated off-site. It came in on a low loader, 35 meters long, and it was lifted into place in one evening. And also inclusive mobility is in here. So you can see the double height handrails. Also, there's privacy screens using extruded metal mesh, which gives you visibility when you look in one way, but privacy when you look the other. And it's also vandal proof. And because you can see through it, then elderly, vulnerable people can see who's on the bridge before they cross, so they can feel safe using it. Uniform lighting to make sure that you don't go from dark to light spots as you walk through, which is important for partially sighted people. And there's no hiding places, so people feel safe to use it. Coming back to Hong Kong, the WE facility, built on, well, actually close to a landfill site. So there's a risk of methane gas. There's an HDPE membrane put here, but also perforated, naturally ventilating gas collection pipes around the building to vent it and keep the gas concentrations below the lower explosive limit, meaning the building is now safe. At this point, I think I'd like to maybe run through, what are the key takeaways of, what we've gone through here, and maybe share some thoughts on this. So the first thing is perfection. Can we really be perfect in design for safety? And I don't think we can honestly say that any of these examples are 100% perfect. And I'm sure as you've looked at these, you can probably find some faults in there and things you can improve on. But that's good, because we should always look for improvement. And if I think we're all thinking in the right direction, we'll make our construction industry a lot safer. But hopefully you found that these examples do provide some insights on a way of thinking that embodies design for safety. And also, I think whole life cycle safety has to be a fundamental. And ALARP is It stands for as low as reasonably possible. And that means that the risk or the cost of mitigating the risks should be proportional to the benefit of mitigating the risk, because you can always go to very extremes to eliminate a risk, but the cost and impact of doing so is disproportionate to the risk itself in the first place. Otherwise, we'd probably end up having none of the schemes actually built in the end. But we do need to consider the whole life cycle of an asset, and that means everything from the concept, the client's first needs and ideas, and following that through. We need to make sure we have a qualified design team on board that know how things will be constructed. A lot of designers don't actually have sufficient experience in construction, knowing how things will be built, what plant will be used, what's the sequence, understand how things will be cleaned and maintained. You know, what does the maintenance team have to do to keep it cleaned? And often with assets, once they're built, 10 years down the line, the client says, oh, it's not doing what I really wanted. I want to modify this now. I want to modify, I want to extend up or across or down or remove a part that's not working for me. So how can that be done safely? And if we're all thinking about that from the start of design, you're in a good place. And ultimately, the client may decide to totally replace the asset in future. So if a designer has thought of the demolition or deconstruction sequence, then safety is considered from that point. There's a lot of consideration that goes into, do I know my site? Do I know it holistically, their inherent risks and how to eliminate them? And there's a lot of work required up front to gather data, do the investigations, the surveys, consider the benefit of advanced works contracts. And the more we can take the guesswork out of the design and how it will actually be implemented on the site, I think the more unlikely will be unforeseen ground conditions. So I think that designers need to be strong-willed to ensure that there is sufficient information at the design stage, well before a contractor gets involved. And I like to think that risks are best dealt by those who are best able to control them. And in the early stages, that's the designer. Now, knowing if my asset can be built safely, so good design has to consider the permanent situation and the temporary situations. Sometimes that means you have to think about the erection sequence analysis and locked-in stresses, and also imagining where each worker will be when each part is installed, what plant will be used, and again, reducing risks on an à la basis. Further consideration is, can I hide behind the codes? And the design codes have evolved over the years, but I think it's very important to understand they don't cover every situation. I've had situations as a designer myself where I've had to design outside of the codes. And if you actually open a code, within the first few pages, it will usually describe the conditions for using it. And designers do need to be responsible to recognize if they have an unusual design, and then consider what can go wrong, devise those solutions, highlight the issues, and also get necessary approvals and verification, or even if it's not a statutory approval that's required, do get it verified by a competent person before it's being implemented. And that really falls into the next point, which is, am I an expert designer? And to be a competent designer, you need to know what are your limits of competence, know when you need to go and ask somebody else for help. So some further thoughts are that we can also look at modularization. And you've seen that in some of the examples. For example, the border crossing facility, the passenger clearance building was a good example of modularization. But it can be units for a building, can be units for a bridge. And it's certainly one of the trends towards industrializing our construction process. I think at the moment, there's a lot of emphasis around MIC, MIMEP, but I think we need to think bigger than that. I think we need to think about automobile scale of industrializing our process to essentially bring our industry into the modern age. We're still languishing a little bit behind other industries in terms of the technology and the process of building. There's still too much in the way of manual operations going on. So I think designers can design assets to allow for modularization. And if we don't design for modularization and then hand it to a contractor who wants to do it that way, it's very, very difficult to reverse a design you've been given to build. Repetition. Design in repetition. We've seen that where you can repeat an element, the learning curve for the next worker who has to deal with it is much lower. The more you can repeat an action on site, the less likely there'll be mistakes, less likely laborers will make mistakes, and that should mean a safer environment. Think laterally. So there's more than steel and concrete, and they're not always the best materials for choice. We've got examples here, the mini Eiffel Tower as a construction material, not using cast iron and going for these polymer substances. So look at the purpose and function of an asset, its components, and consider, am I actually using the best material for the application? And the favorite question I think we should always ask ourselves, can I change the light bulb without working at height? And also to minimize exposure. So realistically, again, on the basis of ALARP, have we done what we can to minimize the exposure? Have we minimized the number of people exposed, the time they're exposed? And if we limit their risk, we can also improve the safety. And digital technology, you can create a digital twin of what you're about to build before you build it. Technology these days is so advanced now that you can look at, is it safe to build, maintain, clean, repair, demolish, remove? And it can all be rehearsed digitally. You can look for all the risks in doing it, and then you can finalize a design. And we also need to be cognizant that designs evolve. That is, from the initial consultant's design to the actual construction, the design changes. So it's also important to ensure that when those design changes are implemented, that everybody involved understands the original design and the original design intentions. And we do see examples of a lot of contractors redesigning elements for safety, speed of construction, economics, or a mix of those. So you have to also ask the question, could the designer have done more in the first place? And I think it is also less fortunate if designers are leaving it to the contractor to redesign permanent works if there are safety inadequacies inherent in the original design in terms of the ability to build the asset. And that means designers thinking far beyond a wished in place asset. Construction techniques also evolve. Time doesn't stand still, and neither does construction technology. And I think you'll have seen in some of the examples I've shared with you, some of the new technology, new methods to overcome the challenges that we traditionally face, and how those can be evolved in future projects. And I think the peanut shaft from dragage is a very good example for that. So in terms of what more could we all be doing as an industry, I would say, let's keep sharing these good examples. The more we share, the more people know, the more people have ideas to implement design for safety at different stages of the project life cycles. And we need to get away from the fact that most of the effort appears to be concentrated at the construction stage. So we need to think at the earlier stages, emphasizing operation, maintenance, cleaning, repairs, provide demolition and removal sequences, and education. Do the designers know how the designs will be built? Some yes, some no. And I think that if we have some clarification on the different designers' roles, we may start to implement a culture change. I think in Hong Kong, in terms of public works, there's a fairly wide adoption of the Development Bureau's Design for Safety guidelines, but it's less prevalent in the private sector because it's not required by ordinance. Certainly, cross-industry collaboration on design for safety will help a lot. So whether it's with IOSH, HKOSHA, Temporary Works Forum, the engineering institutions, the architectural institutions, construction clubs like the Lighthouse Club, the Construction Industry Council, the contractors associations, the consultants associations, we can do a lot more to collaborate across our industry. Also, a little bit of a plug here, but also taking it seriously, is the Lighthouse Club, outside of COVID times, has also been organising an international design for safety competition. And this is another way of promulgating great examples of design for safety and recognising those great individuals who are practising it. I think that as an industry, and particularly in Hong Kong, we can also lobby our different industry bodies to in turn lobby the Hong Kong government for a Hong Kong version of the CDM or design for safety regulations. All these things do need to be tailored very specifically to Hong Kong, because Hong Kong has its quirks. You can't just simply copy and paste from another country, but perhaps a lot of the principles can be transferred over. So this really concludes my talk on design for safety, a consultant's perspective. Do please feel free to reach out to me on this email address if you have any queries following this presentation. I do also encourage you to look at the Lighthouse Club website, Lighthouse Club Hong Kong. For those of you outside of Hong Kong on this call, there is Lighthouse Club in the UK, there's Lighthouse Clubs throughout Asia, and there's also Lighthouse Clubs in the Middle East as well. But also think from today, what were your favourite examples? What sticks in your mind? And what are you going to be thinking about when you go back to site, when you go back to work? What are your thoughts about it? So at this stage, I think HY Raymond, I'd like to say thank you everybody for listening to me for the last hour or so. And I'm happy to open up for questions. Thank you.
Thank you, Robert. I still handling some message from the member. Anyway, I share my PowerPoint first, and some question already typed in our PowerPoint.
Okay.
Okay, maybe leave your side first. Okay, now we start the Q&A session. Wait a minute. I share my PowerPoint.
Thank you.
Okay. Okay, we got one first question from Andy. Okay, Robert, have you seen the question? Yeah.
Not yet. Can you? I think you need to go down to the next slide.
Okay, again.
You're just on the Q&A slide, HY.
Have you this?
Okay, that's it.
Okay.
Yeah, just
again, no problem. Okay.
Isn't the tech wonderful?
Okay, this one, get it?
Okay, I can see it now. Okay,
Okay.
Let's see how I
the
can answer
question from Andy.
Yeah. So, hi, can I ask how safety practitioners can assist our designers in design for safety? How can we work together and support design for safety? So let me deal with that first part of the question. So I would say that as part of the, and we saw this in the example from Gammon when they were looking at the plenum design, and also from the M+, in fact, the M+ situation with the Arab. Design for safety reviews were conducted at 30, 70, and 100% of each design stage. I think that safety practitioners, whether you come from the consultancy side or whether you come from the contractor side, all have a role to play, either formally reviewing designs for design for safety or informally reviewing. And certainly if you're, say, in a site position and you see something that you believe is inherently unsafe or could be a lot better, safety is everybody's responsibility. And therefore, you're able to voice up and give your opinion, provide your advice, make sure that it goes back to the managers and directors who are responsible, and that it gets passed back. In that way, safety practitioners are doing what they can. Ultimately, if it's enacted through legislation, the second part of the question, then that can become a compulsory part of the process. But how can we speed it up? I know that, and I believe that CIC has also been talking about this issue with government as well. So hopefully this is, an example of one construction industry body pushing for some sort of engagement with the government on design for safety to improve it. But I think if we all contact our respective engineering institutions and bodies, particularly in Hong Kong, and lobby for it, the more people that ask for it, the more likely it is that people will get round to implementing it. So I hope that answers the question.
Okay, thank you. So we go to the other question from John.
Okay. Yeah. Okay. Yeah, so this is dealing with the clients, and have they looked at design for safety before the contract stage? So very good question. And this comes back to clients, I believe, also do have a liability within design for safety, because ultimately they are saying, I want this to be built, or I'm choosing from a master plan to do it this way. I'm making a choice. The moment they make a choice, they're also making decisions around design for safety. So there is a question around, are clients educated and understand the risks? There's also a question mark around, does our industry and industry-wide personnel understand the risks? Certainly, I'm sure for those of you from the UK, design for safety is probably now built into professionals training, and anyone working in the UK would have to be compliant with the CDM regulations in the UK, likewise in Singapore. So I think that in those countries, it's covered. Hong Kong, I don't know if it's covered in the university courses, but certainly it should feature quite heavily in training. I would agree with that. So if you are involved with educators, I'd recommend discussing with the educators if they're including it, and perhaps put some pressure on them to also include it. So hopefully that answers this question.
Okay, thank you. So I think John will have another question. Anyway, we go to other member first. Okay, from KB.
Yeah, it's an interesting point about the good concepts being manifested at the construction stage, but that's probably reflective of the fact that a lot of designers are not doing it. But it also shows the ingenuity of contractors to come up with even better ways of constructing, because they're not doing it just for design for safety. Of course, they'll be doing it for other reasons as well, speed of construction. They are obviously concerned about safety of their workers, but they're also cost implications. They're all interrelated. So it's not unsurprising that we see a lot happening at construction stage. I do wish we saw more at the design stage. I think there's an awful lot more that could be done. I think if there was more review from safety practitioners at early stages, and that became a compulsory process, then that kind of independent oversight would probably put more emphasis on design for safety being built in at the design stage.
Okay.
So that would cover the whole life cycle, which is there. Is there any study or assessment on the application of design for safety on the private building sector, like residential buildings? I personally am not aware of any such studies, and certainly if I walk around Hong Kong, I've seen some probably quite horrible examples of, at least in my view, of safety by design, or lack of it, I should say. There are some forward-thinking developers who very much are considering design for safety in Hong Kong. So it's not all negative. There are some good developers out there for sure, but I'm not aware of any particular study or assessment. It's much harder in the private sector where we need the private sector to come forward with their data.
Yep. Okay. Thank you.
Next question then.
Yep. That's from this question from Stephen. Like some.
Yeah, the CIC indeed has been promulgating, materials. That is correct.
Okay.
And yes, totally agree that people should be applying the general requirements and principles as appropriate to their projects. CIC is one of the good industry bodies that does put out this information.
Okay. For refer the Stephen mentioned. Yep. Sorry.
Yeah, I was going to just add on here that the Stephen has a very good point about the duty holders, and at the moment, I would say that there are people who should be duty holders who are not actually taking ownership of the issue, and that's one of the reasons why I think that legislation is needed, because without the legislation, there's a lot of people who are skipping the issue, and we're going to lose that opportunity to improve our safety record as a result. So thank you for that. Next.
Okay, so I not enough the time to copy the whole process. So I think I further read the chat box from the members. HP1 is Roger. Like Roger will have one question regarding the training. From his question one, could if anything possible, recommend design safety and be part of the safety officer training course? That's the first question.
It's obviously not within my remit as a consulting engineer working for Bureau Happold, but certainly I would certainly endorse design for safety being included in training courses, not just for safety officers, but across the board, because I think it is one of the overlooked areas in construction. There's too narrow a band of people that are educated in this area.
Maybe one topic for the safety officer course for the design for safety. Okay, the question two is for safety, design safety intent and initial input shall also take into the account of future repair and maintenance. So maybe okay.
Yep, I totally agree with that. So what people need to think about when undertaking a design is if something gets damaged, if a facade, a window, if I have to do a bit of concrete replacement or steel replacement, how do I get in to do it? And really, if the designer has thought about it, I mean, one of the best examples I can recall seeing was actually for a bridge design. It was a German design. I can't remember the name of the bridge, but I do remember the detail. It was a steel twin box girder highway bridge, so quite a large structure. And consideration had been given to the fact that the steel might rust and decay over the years. And if it was left to continue, it could become structurally unsound. So the designer had built in from the beginning a methodology for replacing the steel panels in that box girder bridge, how to frame it, how to cut them out, how to put the new one in and restore the structure to its full working capacity. And I thought that was a very good example. If designers are thinking about how to repair things and build in permanent features into their buildings or assets to begin with, then I think it's going to be much safer for people to operate the premises later.
Okay. At the chat box, thank you, Stephen, to place the link regarding the guidance from CIC Hong Kong website. Thank you. And one more question from Duran. Duran mentioned what training and how you think the industrial needs to equip all relevant people be ready to kick off.
Is this, if I can just rephrase the question, is this basically how to get the industry trained in design for safety?
Mm-hmm.
So I would say that as professional engineers like myself, there's something that we have to do called CPD, continuing professional development, which includes attending webinars like this. And that's one way. That's one way that people can pick up the training. But I think it also needs to be in grassroots training. So in the property sector training, in the engineering training. So I would say vocational courses, university degree courses. I would say even training courses for workers on site. I think if workers are educated, even if frontline workers are educated in design for safety, it creates an awareness that they perhaps didn't otherwise have. And if they have that awareness, they're probably more likely to raise issues. They might realize, actually, there's a better way of doing this. Why aren't we doing it? And they can raise it and have the issue dealt with. And if that means the works are built in a safer manner, then I think that's great. But it has to be, I guess the training would have to be tailored to the audience, so that they appreciate what they're being taught, for their level. But yes, absolutely endorse it.
That's mean not specific training in Hong Kong so far?
I don't know if anyone on this call is aware of any outside of the the formal education for degrees and things like that. I'm not aware of any specific design for safety training in Hong Kong, and I think the reason for that is because it's not legislated for. Whereas if you go to the UK, there certainly is. Now I can see Stephen Coppin is putting up a note about just flipped up. CIC is going to start a design for safety training course. So that's a good starting point. So thank you, Stephen, for that.
Okay. We're going to go through try to handle the question. Also regarding ISO course, some construction design concept like design input such as local, legal, and other requirements for construction, like construction design requirement and fire emergency requirement under the reference cap 123. Okay. The building audience cap 95, cap 406, and so on. Roger, I think. Sorry, Roger. I think this question. Maybe I get some more information and then reply to you. I don't think Robert can reply this question. That's regarding the anyway. I go through the other question.
Sure. Okay.
Okay.
So certainly, when it comes to legislation, design for safety specifically isn't picked up. So whilst safety in construction is picked up, design for safety is not specifically catered for, and certainly not adequately.
Okay. Okay. I think the last question. Last question. Pretty accident word example. CIC proposing a launch 2-day. Okay. Thank you, Stephen, to give information. He mentioned CIC are proposing to launch a 2 days design for safety designer course, together with half-day design for safety awareness course later next month. Do you know this course already from CIC?
Yeah, I'm not aware of this course. I mean, it's a third-party provider providing the training. I think it's great that the training is being provided. That means that more people should get educated about design for safety. I would perhaps question the audience that's being targeted, and the people that are being invited, and whether it's wide enough. But hopefully that's all in hand by CIC.
And then thank you, Andy, to give more information. He said currently there is a 3 hours DFS training course in CIC and Occupy OSHC as part of the SMS course. Thank you, Andy.
Yeah.
Okay. And okay.
What I would say is that we need more than just CIC. It's great CIC is doing a 2-day course, but I think that we need other providers as well to join in the mix. If we think about the UK and the opportunities for the equivalent of design for safety training there's multiple providers, multiple perspectives, and also tailoring to different audiences. So it's great to hear on this call about the CIC training, but let's try and push for a wider number of trainers, I would say.
Yes. Anyway, thank you, Robert, for giving some good DFS example information from the PowerPoint. Refer the approval from Robert. He will share his PowerPoint for uploading to our website. But we need to remind all of you that's all for our IOSH member information only. Don't share to others. Okay. Thank you, Robert, again.
Okay.
Thank you.
Thank you, HY. Thank you, IOSH. Thanks for having me today. Much appreciated.
Okay. I want to announce some information from our member for coming event. Maybe 3 minutes. For coming event, 14th of March, we will have other webinar regarding the 3C, 3P model for the industrial safety system. Another webinar regarding the new blueprint and CPD platform at the IOSH website. And one more thing, call for nomination. Our EC member will end of this March. So some new EC member will welcome for self-nomination to our further rep. For the deadline is the 24th March. Okay, thank you again. Thank you, Robert, again. In any new information, don't forget me, share with me. I will share to other members. Thank you, Robert.
Okay, thank you, everybody.
Thank you, all of you. Thank you.
Okay, cheers.
Bye-bye.